All right, so welcome to the next video. So in this video, we're going to look at the moment and shear functions. All right, we're going to develop these moment and shear functions. In the last video, we found the reactions to our beam. So we have our beam here again. Let's redraw our reactions. So we have our AY is equal to 178 kilonewtons. And then we have our moment going this direction, acting at this point. Our moment was 958 kilonewton meters. Let's draw our diagram first. We have our shear force diagram and we have our bending moment diagram. First thing that we need to do to find our functions is cut the beam into sections. So we're going to cut a section there, we're going to cut a section here, we'll cut a section here, here, and here. Okay, so we're going to end up with 5 different sections. So these are where we have changes in forces. We have a zero force here, we have a linear increasing force here, we have a change in force here, here, and here. So let's redraw this cut section here. We'll have a beam that looks kind of like this. It's cut here. We have a reaction, 178 kilonewtons. We have our moment, 958 kilonewton meters. Then we have our shear. Our shear, we call it V1. And we have our moment, we can call it M1. And then we have our distance, will be X1. Let's write our function, our first one. So our V is a function of X1. We have our negative V1 acting down. We go negative V1. And we have a positive 178. Positive 178 kilonewtons. And we don't have any other forces, so that will be equal to 0. So our V1 is equal to 178 kilonewtons. And then our moment, function of X1. So we have our positive M1. M1, we have a positive 958 kilonewton meters. And then we have a negative 178 acting in this direction at a distance of X1. So negative 178 kilonewtons multiplied by X1 meters equal to 0. So our M1 will be equal to 178 kilonewton meters minus 958. And we found, so this will be our M1 and we have our V1. So we found our first distance, right? Up until this point, to our X1. All right, so let's find our X2. So our X2 will be this distance up to here, up to our 5 meter point. So we'll have X2. So let's redraw our beam. This distance is 1 meter, and this distance will be X2. And then we have our reactions, same as before, 178 kilonewtons. And this reaction was 958 kilonewton meters. We have a shear, we'll call it V2. And we have our moment, which we'll call M2. All right, so let's write off Vx as a function of X2. So we can write, we have our negative V2. We have a positive 178 kilonewtons. And then we have force here acting down. All right, so we don't know what this point is. We have no idea what this point is because we haven't defined our X2. So we can cut this into 2 sections. We have a rectangle and our triangle. So our rectangle is pretty straightforward. The force will act halfway of X2 and the triangle will act 1/3 of X2. So this will be 1/3 and the rectangle will be 1/2. So let's find the forces of our shapes. So we have our rectangle, and this is 12, this is X2. So our force from our rectangle will be negative 12 X2. But our force from our triangle, we don't know. So if we go back to our top triangle, so we're looking at this triangle here. And so say if this point is 0, this point will be 20. This point will be 20. So the difference is 20. So if we redraw our triangle here, we can draw a triangle. We have 20 here, 0. We want to find a point somewhere here, and we don't know what this point is, right? We don't know what this point is, and we know that this distance is X2, and the total distance in blue is 4 meters. Right, if we look at our beam, our total distance from here to here is 4 meters. Triangle will be 4 meters long. We want to find this point, and we also know the area of this triangle be half the base times the height. So we can plug in here, we're going to plug in X2. We know this is our distance, but the height, we don't know. We don't know what this height is. So here, this is our height. We can use similar triangles to find our height. So we can write 0 minus 20 divided by 0 minus 4 meters. And this will be equal to, I'll write it in a different color. So this will be equal to 0 minus h divided by 0 minus X2. If we solve for h, we'll find h is equal to 5x2. So we can plug in 5x2 into here. And then we can find the area of our triangle. So we can find our force. So if we come back to our equation, we have a negative 1/2 times x2 times 5x2. And all of this will be equal to 0. And then we can find our moment. Moment is a function of x2. So we have a positive m2. We have a positive 958. We have our negative 178 acting in this direction. 178 kilonewton meters, and the distance is 1 plus x2 meters. And then we have our two forces. So we know our forces. This is the force from the rectangle, and this is the force from the triangle. We just need to multiply it by this distance. This for our triangle, and this distance for our rectangle. So we'll have our moment from our triangle and our rectangle acting in this direction, right? So they'll be acting in the anti-clockwise direction. So it'll be positive 12x2 multiplied by x2/2. And then we'll have a positive 2.5 x2 squared multiplied by x2/3. And all of this will be equal to 0. If we solve for m2, we'll find this to be our moment function. So now we found our x2 and our x1. So then we need to find for each section. We can find for each section. So this will be x3, this will be x4, and this will be x5.